Part 3 of the final exam review covers chapters 6 and 7. So remember, this is the part of the final that is going to be the least amount of problems because it is the most recent stuff we've covered. So I'm not going to do an example of everything from chapter 6 and 7. I'm going to do some things for means, some things for proportions. So you could be asked to do any of these things for means or proportions, which means you have to know how to do both. The other thing that I don't really review but could be on the final are questions about conditions. So random, independent, and normal. And those would show up in the true, false, multiple choice, or fill in the blank on parts 1 and 2. They're not going to show up on the short answer part, but you do have to know the conditions for a significance test and a confidence interval. So in our first problem, we have that the average number of students in a high school class is said to be 25.4 with a standard deviation of 7.8. So this is an example of means, so you would also need how to do this for proportions. If 35 classes are randomly selected, what is the probability that they have an average number of students between 22 and 28? So we are trying to find the probability that our mean is between 22 and 28. Now, it's not like in chapter 5 where we could go straight to normal CDF. Because I now have a sample size bigger than 1, I have to take my standard deviation and I have to calculate my sample standard deviation. So I take my population standard deviation of 7.8 and we divide it by the square root of n, which is 35. So I have to distribute that across my entire sample. And that gives me a new standard deviation of 1.318. And that's what I'm going to use in normal CDF. So my lower bound is 22, my upper bound is 28, mean is 25.4, and my new standard deviation 1.318. You can also calculate your test statistics, your z-scores, and you do it that way as well. So we get a probability of 0.9708. The next one says if 41 classes are randomly selected, what is the probability that they have an average number of students less than 30? So we want to find the probability that x bar is less than 30. So again, I have to calculate my sample standard deviation. This time it's going to be 7.8 over the square root of 41, which becomes 1.218. So when we go to normal CDF, because our probability is less than, our lower bound is negative 1e99. Our upper bound is the 30. Mean is still 25.4, and our standard deviation is now 1.218. And we end up with 0.9999. So it's almost guaranteed that the average number of students is going to be less than 30. Next, we have that a researcher wishes to estimate the mean salary for a beginning zoologist. In an SRS of 41 beginning zoologists, it was found that they had a mean salary of $31,782 with a standard deviation of 1,456. Compute and interpret the 90% confidence interval for the mean. So you have to know how to do a confidence interval for means. You also have to know how to do a confidence interval for proportions. For means, you have to first decide between a t-interval and a z-interval, and that's based on the standard deviation you're given. So this is going to be a t-interval because we are given sample standard deviation. So I would definitely include this on your sheet of notes. A t-interval is used if you have sample standard deviation. A z-interval is used if you have population standard deviation. So I have to calculate my t critical value, which you do INVT. And then to get your area, it's the remaining area to 100% divided by 2. So that would be 0.05. degrees of freedom is your sample size minus 1. So our sample size is 41, so our degrees of freedom are 40. And then we ignore the negative here when we get out our critical value, and we get 1.684. And the reason we ignore the negative is because our formula has that plus or minus, so we account for it there. So our formula is x bar plus or minus the t critical value times our sample standard deviation over the square root of n. And this is on your formula sheet. You don't have to have it memorized. So you have 31,782 plus or minus 1.684 times 1456 over the square root of 41. So you do have to write this part down when you're showing work. I have to know what you use to calculate your interval. You can then just give me the interval. You don't have to show me any work between this step and the actual confidence interval. So when I do the 1.684 times 1456 over the square root of 41, we get 382.92. I'm only going 2 decimals here because this is money. So we only ever go 2 decimal places with money. When you write the confidence interval itself, the smaller number has to come first, the bigger number comes second. So the subtraction comes first, addition comes second. So when we subtract, we get 31,399.08, and we add, we get 32,164.92. And the last step is to write the sentence. So we are 90% confident that the true mean salary for a beginning zoologist is between, and when we write this sentence for means, we do have to include units on the values for our interval in the sentence. So in this case, it's money. So $31,399.08 and $32,154.92. Next problem says, does right or left-handedness affect how fast people type? Random samples of students from a typing class are given a typing speed test in words per minute, and the results are compared. Find and interpret the 99% confidence interval for the difference in typing speeds between the two groups. So this is a difference in means confidence interval. So you also have to know how to do a difference in proportions. Anytime you have to do a difference in means or a difference in proportions, you have to define x1 and x2. I'm going to choose x1 and x2 so that when I do my difference, it's positive. So I'm going to let left-handed be x1 and right-handed be x2. You can define it any way you want. Again, as long as you indicate to me, I will grade based on how you define your variables. So again, this is going to be a t interval because we are given sample standard deviation. So when we do INVT, our area is still the remaining percent to 100 divided by 2, which would be 0.005. Our degrees of freedom, when we have a difference in means, it's the smaller of n minus 1, which in this case, that would be 38. So we end up with 2.712. So the formula for the confidence interval is x1 minus x2 plus or minus our t critical value times the square root of standard deviation 1 squared over n1 plus standard deviation 2 squared over n2. So we're going to have 59.3 minus 55.8 plus or minus 2.712 times the square root of 8.7 squared over 46 plus 4.3 squared over 39. And again, I will always show all of the work. You just have to set up the formula and you can give me the interval itself. So we'll have 3.5 plus or minus 3.948. And again, we always have to put the smaller number first, so the subtraction first, so negative 0.0448. And then we do the addition, and then we get 7.448. And then our sentence. So we are 99% confident that the true mean difference in typing speeds between left and right handedness is between negative 0.448, and then units are going to be words per minute, and 7.448 words per minute. And you are allowed to have a negative here in the confidence interval. That would just mean that there is a chance that right-handed people are faster typers than left-handed people. Next, we have that it is said that the proportion of students bullied in a school year is 38%. A researcher believes this is too high and collected data on an SRS of 50 schools and found that they have a proportion of 19% of students who are bullied. Is there evidence to support the researcher's claim that alpha equals 0.01? So this is a significance test, which means we have a null and alternative hypothesis. So this is an example of proportions because we're given percentages. You also have to know how to do this for means. So we start with our null hypothesis. And because it's proportions, we'll have P equals, and it'll always be what they claim, which in this case is 0.38. The alternative hypothesis is based on the wording of the problem. So they believe it's too high, so they believe it's less than 0.38. Our P hat is given to us 0.19. So now we're going to calculate our test statistic. So we're going to do our P hat 0.19 minus our claim 0.38 over the square root of 0.38 times 1 minus 0.38 all over n, which is 50. And we're going to get negative 2.77. Now we don't ignore the negative here because for a test statistic, the negative does mean something. It means that we fall below the mean. So my lower bound is going to be negative 1E99. My upper bound is negative 2.77. Mean of 0 and 1 because this is now a z-score. And we get 0.0028, which we now compare to our alpha. And this is less than our alpha of 0.01. And anytime your p-value is less than your alpha, you reject your null hypothesis. So for our sentence, that would mean there is enough evidence to show that the true proportion of students bullied is less than 38%. So again, your sentence has to state the conclusion in the context of the problem. Now we're going to talk about our type 1 and type 2 error in the context of our problem and then determine which error could have been made. So again, I would write this down on your sheet of notes. So type 1 error is when you reject and you should have failed to reject. So that would mean you determine that less than 38% of students are bullied when they aren't. And then a type 2 error is failing to reject when you should have rejected. So you do not determine that less than 38% of students are bullied when they are. Okay. And then when it comes to which one we could have made, so again, because we rejected, we could have made a type 1 error. So could have made because rejected HO. Next, we have that in Cleveland, a random sample of 73 mail carriers showed 10 had been bitten by an animal during 1 week. In Columbus, in a random sample of 80 mail carriers, 16 had received animal bites. Is there evidence to show that the proportion of animal bites is significantly higher in Columbus than in Cleveland? Test at alpha equals 0.05. So this is a difference in proportions significance test. So we also need how to do a difference in mean significance test. So my first step is to define P1 and P2. And I'm going to define P1 and P2 so the proportion for P1 is higher. So P1 is going to be Columbus and P2 is going to be Cleveland. For the null hypothesis, it is always that the proportions are equal, so P1 equals P2. The alternative hypothesis, so we would know if it's higher in Columbus, so my alternative would be that P1 is greater than P2. So for a difference in proportion significance test, we need to calculate our P1 and P2 hat, and then we also need to calculate our pooled proportion. So P1 hat is going to be 16 over 80, which is 0.20. P2 hat is going to be 10 over 73, which is going to be 0.137. And then our pooled proportion is our successes. So 10 plus 16 over 73 plus 80, which is 26 over 153, which is 0.1699. So our test statistic, our numerator subtracts is P1 minus P2, so 0.20 minus 0.137. Our denominator uses our pooled proportion. So it's the square root of 0.1699 times 1 minus 0.1699 over N1, which is 80. And then same thing in our second fraction, 0.1699 times 1 minus 0.1699, but this time over N2, which is 73. And that is going to give us 1.036 for our test statistic. So then we get our p-value by doing normal CDF. Our lower bound is 1.036. Upper bound is 1e99, mean of 0, standard deviation of 1. And we end up with 1.1501, which is greater than our alpha of 0.05. So when it's greater, we fail to reject our null hypothesis, which means there is not enough evidence to show the true proportion of mail carriers in Columbus who get bitten by an animal is higher than the proportion in Cleveland. Last thing we're going to talk about is solving for necessary sample sizes, and I am going to do an example for means and proportions here. So we have a soccer ball manufacturer wants to estimate the mean circumference of soccer balls within 0.1 inches. Determine the minimum sample size needed to construct a 99% confidence interval for the population mean. Assume the population standard deviation is 0.25 inches. So we need three things to calculate our sample size. We need our margin of error, our standard deviation, and our Z critical value. So our margin of error is the 0.1. Our standard deviation is 0.25. And then our Z critical value, which we do INV norm to calculate. And then our area is still the same thing though, remaining percent to 100 divided by 2, which is 0.005. We get 2.58. And then for our formula, it's our margin of error, standard deviation, 0.25, times our critical value, 2.58, over our margin of error, 0.1 squared, which is 41.6. Now, we have to always round up. So that's going to be 42, and then our units, which is soccer balls. So one thing to always remember when solving for sample size, always round up. Now for proportions, it works a little bit differently. So we have an automobile manufacturer would like to know what proportion of its customers are not satisfied with their service. The customer service department will survey customers and estimate a 95% confidence interval for the proportion who are not satisfied. If past studies suggest that the proportion will be 0.2, find the sample size needed to have a margin of error of 0.015. So again, we have to have our margin of error, which is 0.015. We need our p hat, which is 0.2, and then we still need our Z critical value, which we do INV norm to calculate, which for 95% confidence interval is 1.96. Now the formula for proportions is your critical value, 1.96, over your margin of error, 0.015, squared, times your p hat, 0.2, times 1 minus your p hat, so 1 minus 0.2. And we get 2731.8, which we'll round up, and we'll get that n has to equal 2732, and then customers. You do have to remember to put units when you solve for n. It depends on what the units are for the problem. Now in B, what sample size would you need if no estimate of the proportion is available? So the margin of error doesn't change. It is still 0.015. But if we don't have a previous p hat, we always use 0.5. And we're still doing a 95% confidence interval, so our Z critical value is still 1.96. So the first part of our formula doesn't change, 1.96 over 0.015 squared. But now it's times 0.5 times 1 minus 0.5, which gives us 4268.4, which I'm still going to round up, and it's going to become 4269 please let me know if you have any questions about any of the problems from any of the parts of the final exam review. And make sure you create your sheet of notes. And if you want me to check it over before the final, please let me know.